Hey everyone, thanks for coming. I've got apologies from Blastamil, he can't make it today. Dave, glad you're able to join us. I know you said you might not be able to, so pleased to see you're able to. All right, so been a busy couple of weeks. Thanks to those who've been sending patches. I've been doing my best to review as many of them as I can that are folio related. I'm not sure I've been doing a great job of it, but I've been doing what I can while also churning up my own patches. So let's see. The NetMem work seems to be going pretty well. I haven't had much of their substantial feedback on last version, but a couple of minor niggles that I need to correct and post a new version of, but that seems to be in progress to go in. I've noticed Andrew Mawson has now promoted a number of patches from the unstable tree to the stable. So those, I guess, are going to go in unless there's something awful that happens between now and the opening of the merge window. I have been busy the last few days working on converting ext4 to Folios. That is not for this merge window, that's going to be for the next merge window. Partly because it is going to rely on the buffer head work, which is in the tree right now. And I want to send the ext4 changes through TED. So I'm developing those against unstable. Sorry, the latest next tree, which includes as well as. Yeah.
Is it still on top of buffer heads, right? It's not converted to IO map or how called?
Correct. Yeah. So I looked at converting ext4 to IO map, and honestly, it's just a little bit beyond what I can do right now. I don't fully understand all the complexities of what file systems are doing in their get block, and what they would then need to do in their IO map equivalent of the get block callback.
And the ext4 is more complicated because they've got JBD2 layered on top of buffer heads.
You know, I didn't even get to that particular piece of complexity. What I thought you were going to say was ext4 is even more complicated because it has support for FS Verity and for FS Encrypt, and I think a third thing as well that also kind of ties in and expects buffer heads. So yeah, there is a lot to do in order to convert.
DAX, yeah.
I'm sorry, what was that?
DAX is another thing.
Oh, DAX is fine. IOMAP already supports DAX because Express supports DAX, so we're good from that point of view. But yeah, we don't have IOMAP support yet for Verity or FS encryption, which is stuff that needs to happen, but you know, it hasn't happened yet. So while I could work on that, again, I'm probably not the right person to work with. I don't have enough experience in those areas. So I've been going through and converting ext4's current architecture from pages to folios. A lot of what there are places which are very hard to convert to support large folios. We have things like an array of buffer heads on the stack, and that array is sized for the number of buffer heads that you need for a folio for a page. So you know, 8 on x86 and somewhat large on other. But obviously I don't want to increase that to the number of buffer heads that fit in a 2 megabyte page. That's kind of silly. I mean, it'd be 4,000 pointers, right? So those functions are going to need some work to figure out how to make them compatible with large folios. So I've just been converting to the Folio API for the moment and putting various bug-ons in the in those functions to say, hey, this needs to be converted before you start enabling large folios. So they're getting, some of the advantages, right? They're getting the removal of the compound head, and it's not great. I'm hoping that those parts are going to be lifted to IOMAP soon. Whether they will, I don't know. But what I'm really trying to get towards is converting all the infrastructure underneath from pages to folios. Plus, doing this work on ext4 lets me see where we may be missing useful helper functions that should exist in the Folio API. I have a couple. I sent out memcopy from Folio earlier, so that's one helper function that really ought to exist. Another thing I have is, it's not even a helper function, it's just a define for the common mask which is used in write begin. So for find get pages, we have FGP lock, FGP create, FGP this, that, and the other. There's a common one that all file systems are using, and right now that is written out in each call site, and so that's kind of silly. It's far more than it's too much effort, basically. So just having a single FGP write begin seems to make sense to me. I need to send that patch out. I've just got that in my local tree right now. Yeah, so that's what I've been working on. Oh, I've sent out a few other patch series, looking at the RMAP code and a few other places. But those patches are all online, or on the neighbors, so you can comment on those there. I'm still thinking about how we handle map count on multi-page folios. Even after Hugh's recent rewrite, which was really good, I really like what Hugh did with the with the per page map count. We're still keeping a map count for each page of a folio, and before we can get to the point where we shrink struct page down to a single pointer, we are going to have to figure out how to deal with that. How do we want to account the number of mappings per folio with just a single or maybe two atomics? I haven't figured that out. I still think we need to do some fairly loose accounting. So, map count might, for example, if it's 0, then it's definitely 0. But if it's 5, then there may be somewhat fewer than 5 actual mappings of it.
I think 1 is also critical, no? Like when you have single.
Absolutely agree. Yes. I think it's also useful to maintain precisely 2, because that's a really common case, right? We fork, and then we have 2 references to it. And after 2, so we fork, we have 2 references to it, and then we immediately tear one of them down. We go back to 1 and know that we're at precisely 1. Above 2, I think it's less critical. I think in those cases we can do an RMAP walk to find out what it really is if we need to. But yeah, imagine that the map count says it's mapped 5 times, but actually it's only mapped once. I think that's okay. It's somewhat less critical, but it's not. It's not suboptimal, but it's not critical that it be precise at all times. And related to that, there's some work with I'm going to mess up his name. I think Yingfei is how you pronounce it, from Intel, whose work he was the guy who came out with the MC Pages work. So he's now doing useful work instead, working on Folios, trying to figure out how we can map more of a folio in a single call. I'm not sure he has it quite right, but it's definitely looking to be in the right direction. I need to spend a bit more time on that. In a similar vein, there's also the flag that David Hildenbrand added recently for to say that the page is mapped exclusive. That is also actually a per page flag, not a per folio flag. And while maintaining 1 bit per page per folio is much less space than maintaining an entire integer map count for each page in a folio, I would still rather not have that information stored per page. I'd really like to get that back to being per folio. So that's something else that I need to look at. I mean, it's all related, right? It's the number of times that it's mapped exclusively. So yeah, need to spend more time looking at the mapping of pages. There are a few other flags we have which are PF-any. I don't think it's too many. Maybe I know that idle and young are currently listed as PF-any. That's actually a lie. They are. It's just a bug, frankly. There are places which set PF young or PF idle. So yeah, they set the idle PG flag or they set the young PG flag on tail pages, but we never actually check the tail pages. We only ever check the head page. So it's just buggy. And nobody's noticed because multi-page folios aren't all that common, or compound pages aren't all that common. And and it's just a performance thing, right? So, oh, this performance thing doesn't happen to work in some cases. Well, nobody noticed. But they shouldn't be PF. They really ought to be PF head or one of the other one of the other page flags that says you use the head page rather than PF. I think that's about it for PF-any flags. Have a quick look. The private flag, and that's going away. Private 2, that's going away as well. Owner priv 1, that's.
How do we replace private flag with?
Oh, we just check whether page private is null or not.
And okay.
Yeah. So private 2, I think we could turn that into PF head. I think NetFS and ButterFS are the only 2 file systems using that today.
And well, NFS isn't using NetFS lib, so it's effectively a third user trying to work on that, but it's a matter of persuading Trond.
Yeah, I heard Trond actually posted some patches folioizing NFS. I haven't seen those patches myself, but Chuck Lever pointed me at them.
Cool.
Owner priv 1 is PF-any. I haven't really been looking at owner priv 1. I don't really know what that's used for. Hardware poison is PF-any. That needs to say is PF-any, but it doesn't matter because in our Glorious Future with the single pointer per struct page, it's going to be its own kind of pointer. So it won't point to a folio, it will point to a hardware poison data structure. And they've got page young, page idle, vmemmap self-hosted. I don't know anything about that. I'll have to look into that. I don't know what that one. I don't know what that means. Folio test head, yeah. Okay. Page head, right. And that doesn't need to exist. Well, it sort of won't need to be PFNE in the glorious future, because they'll isolated. That's an interesting one. I'll have to look into page isolated. Yeah, that's it. Okay, so I need to look into page isolated, owner one. One. And vmemmap self-hosted. Okay. So we have a bunch of flags, of course, which are stored in the second tail page. That's not a problem. When we do a multi-page folio allocation, we just allocate a second flags word. It's not a big deal. It's really the ones which are any, because that does involve allocating a different size folio for each size of large folio, which is that's quite the burden. I mean, it's a lot of slab caches. So I would rather not do that. I think that's about all I had for this week. Who wants to go next?
I can go next.
Sure.
Well, I've been working on rolling pinning out into various things, trying to shrink my patch set down to just do the bios and then CIFs in this merge window. Christoph is Helwig and Jens are reasonably happy with the bio patches, though I had some more patches to try and make use of the right flags in IOCB and IOMAP and whatever, rather than you relying on the data source in the iterator. Except that's turned out to be somewhat more complicated than I thought, because there's a bunch of places that don't actually set these flags when they should. The problem is finding them all. So hopefully I'll get in just the new extraction function and the bios and CIFs in this merge window. That will at least get us some way to fixing that up in the next cycle.
Can you put in an assertion that the two match?
Well, my thought is I'll add an IOCB read as well and assert if you don't give one or other of them. But Christoph asked me to defer that to the next cycle.
Yeah,
but yeah,
enough.
I thought you should just add a read and a write flag in IOCB, IOMAP, and check that one of them is supplied and give a warning with a backtrace if it isn't. That's probably the easiest way to find them, and put it in Linux Next right at the front of the merge window, the development part of the cycle. Found a lot of them, but I don't know how many there are, because there's various file systems that call their own write iters functions from ioctals or read writer functions from ioctals and call them directly. And I don't know they exist unless I go and mechanically try and find them all, which could take a while.
And people can be adding new ones all the time.
Yeah, so the thing I definitely want to do is put in a warning to catch people not supplying out the bit set. That's the easiest way to find them. And it just has to be print a warning and do the operation anyway. For now. The other thing I've been wondering about is, so we added the pinning to deal with direct IO reads, racing with fork. It only half fixes the problem, I think. The problem is you can have a direct IO read and a direct IO write on the same page at the same time. And then then the problem will recur, I think. Because the direct IO write will get a reference on the page, which will cause the undesired behavior to crop up. So we may actually have to fix it in fork.
I don't think it's fixable in fork. But what might fix it if direct IO writes also take a pin instead of a ref.
Yeah. The problem with that maybe is what happens if you start the direct IO write, you fork, and the child writes the buffer. What will the direct IO write see if it hasn't happened yet?
Well, it doesn't matter, it's indeterminate.
No, it should surely it should only see the parent's address space. But if the copy on write then happens and the page that was shared now only belongs to the child, then the child will change the data and write will reflect what the child did, not what the parent hasn't done.
No, but if the child is the one that's causing the copy on write, then the child gets the copy. The child doesn't get the original page.
So why does that go wrong in fork? Or does fork explicitly copy on write pages with multiple refs on them?
Yeah.
So why can't fork do the ref the other way? Well, just give the child a copy. Because the child doesn't exist yet, or the child is in his process of being set up. Why can't he just get the copy? And if it does get the copy, can we get rid of the pinning stuff entirely?
I don't know, I get confused by all this stuff.
Could you reiterate the problem once again? I phased out a bit.
So the problem is that if there's a if a process starts a direct IO read and then forks before the direct IO read is complete, without the pinning infrastructure, there's a reference on the page that's the destination for the read. That will cause fork to put that page into the child and the parent will get a copy. And when the read completes, the child will get the result of the read, not the parent. So at least this is as I understand it. So we added the pinning stuff so that the parent gets the original, and then the ref is the copy is made to, well, the child gets a copy at some point, but I'm not sure where.
I remember that Linus had strong opinions here, and His response was like, don't do that.
Yeah.
Basically, don't share a page you write from direct.io.
Yeah,
Yeah.
direct.io write doesn't cause a copy to be made because it's not changing anything.
Yeah, I mean, write to the page, so direct.io will read.
Yeah. So write will not cause a copy on write to happen. But what if the parent starts a copy on read and a copy on write to the same page and then forks?
Just don't like.
I
think
you can
best
rely
idea
on user space sometime doing this. So we have to deal with it. So the problem is if the copy on write, having taken a reference on the page, causes that page to get moved to the child and a copy made to the parent. That means the direct.io read is now going to read into the page that belongs to the child. And also, if the child makes a change to the page, it will affect where it will affect what the result of the IO, the copy and write.
I don't get why you say that a child will get the copy. So
because there's a page that's the data buffer for both the read and the write, a direct read and a direct write. So fork, apparently, as I understand it, if it sees that the ref count is incremented on the page, gives the page to the child and gives the parent a copy. But if it's pinned, it doesn't do that. At least that's how I understand it, and I may well be wrong on this. I have no idea.
I believe the child should get the copy and parent live with the original.
So why do we need the pinning infrastructure? Because as I understand it, this is what the pinning infrastructure is for. It's to make sure that the direct.io read affects the parent's address space, not the child's address space.
One says that pinning is the way to say that page might potentially have elevated page count for a long time. That's why we have pin compared to like normal references.
Yeah, but why do we need the pin? What does the pin do?
Yeah, my head always hurt when I try to reason about that.
Because as it was explained to me, it stops the page getting copied the wrong way in fork. But without diving deeply into the memory management stuff and trying to work out where this happens myself.
So I look at copy present PT, which called from on fork.
Mm-hmm.
And it basically checks if page So yeah, it checks if page is pinned, and if it's pinned, it gets copied on fork, and child gets a new page. It's in the memory.c.
So it works that way around. Okay. So what happens if it's not pinned? If it's just got a reference?
If ref count elevated nowadays, I believe that we still copy. So ref count has to be 1, I believe, to make copy and write.
So what happens if it's both pinned and got? So there's DIO read and a DIO write going to that page?
I believe it will get copied.
And who will get the copy? The child.
A child, yes.
Okay, that's fine then.
I remember that I fixed similar bug for huge pages when I tried to cut some corners and parent get a copy on copy and write, and yeah, it broke VFIO. So there is some code that actually relies on this behavior.
Yeah. So, so why again do we need pinning then? Why can't direct IO read just increase the ref count and then it will get copied to the child? The page will get copied to the child and the results will get in the parent's address space.
I remember that there was some semantics around how write back will work, and yeah, you need to ask Jan Kara or somebody who actually was involved heavily in that part. I didn't follow that compose.
I'll go and ask Jan then. At least I have a name to start with. I think we should move on from this now.
Yeah, that's a great episode. All right. What is there anything else you're working on you want to talk about?
That's been it so far, apart from moving from Stat Git 1 to Stat Git 2, which is now uses git send email. But apart from that's something different. Well, the problem is that it doesn't work with the tools I have for constructing cover pages and stuff, because anyway, that's not really memory management matter.
All right. Kirill, anything you want to talk about?
I don't have anything for this forum, but maybe it's okay to ask some VFS question here.
Sure.
I have problem with like for TDX stuff. We did restricted memfd. If somebody saw that part, that prevents that basically file descriptors that can be used for KVM to allocate and free memory to allocate memory for without mapping it to user space. So it's a new file descriptor that the sole reason why it exists is to allow KVM and potentially other VMs to allocate memory for the guest. I tried to implement it initially on top of like modifying TPFS, and he was not happy about that. So I implemented this as shim layer on top of TPFS. Basically, I have two inodes. One inode that belongs to TPFS, and one inode that tied to file descriptor that exposed to user space. So user space will not have access directly to the data. This approach works, but it has limitations. Like I need in the future to hook up migrations there. Like the page need to be, when page get migrated from one place to another, there should be a hook to allow KVM does its things to preserve the state. And the problem is that from core mem point of view, the page is just normal TPFS page. So it will see migrate folios that belongs to TPFS. I try to consider my options here, how I can make TPFS, make ORMM report to whatever hook I need. Is there any precedent when we override address space IO for a mapping? So is it okay for me to override TPFS IO with my own hooks? Is there any problems with that? I saw that it will not consider, this mapping will not consider it shmem mapping anymore, because it's how we check if it is shmem mapping or not. But other than that, is it like okay or not?
So are you talking about rewriting the address space operations table for file system?
Yes. So
Well,
I allocate page from TPFS, but I want my own address space operations.
Yeah, I think that's fine.
as long as you call through into the backing file system, maybe.
Well, not necessarily. I mean, the backing file system here is always temperfest. It really,
Alright.
temperfest is almost irrelevant.
Yeah,
It's just that temperfest is kind of a library of in-memory file system routines.
In the future, I may need also huge CLBFS, for instance, but it shouldn't be a problem too.
yeah. We've had some issues with third-party software rewriting the address space ops and the file operations, and then crashing because someone added another one or something like that. But that doesn't apply to you, I presume.
No. And frankly, I don't want some of operations error anyway, like write page. I don't want anybody to write to the page of this market.
Because there are actually several file systems that are built on top of Shmefs, whatever you call it. So
Yes,
Ramfs
and TMPFS and System 5 shared memory is also there.
Yeah.
And who else? Intel driver, Intel graphic driver also uses.
Yeah. So it should be
i950.
Okay, thank you. That's all I have.
Cool. Thanks, Graham. All right. Bill, you're next on my list.
Nothing important. I've thrown a few reviews over the fence over the past week, so that's about it.
Yeah, I saw those. Thank you.
Okay.
Appreciate those.
Cool.
Vishal, what do you have for us?
So I was looking at migrate page add in mem policy, basically, and just started looking at migration stuff. And it seems pretty straightforward and simple for not large folios, but when I got to large folios, I started getting a little confused with the map count connection stuff. Because a couple places use page map count on like the head, and like somewhere in migrate, it also uses page map count on not the head before doing things. And I guess I was just a little confused about if switching that to folio map count would be fine, because my understanding is that we'd want to avoid migrating a page that's shared with others, and so I would think we would want total map count to be there instead of page map count on the head, but the current code has page map count on the head, so I'm like, I don't know what I'd want to change that to.
Why do you want to avoid migration if map count is like if mapped multiple times? It should be perfectly fine.
You know, I am not entirely sure at the moment. It's just what the code is doing everywhere, so, or some variation of that everywhere.
For huge page, there is like special case when we migrate misplaced page for NUMA balancing that expects only one mapping. But in general, like for THP, we can migrate page that mapped more than once. It just requires that every place where it's mapped will be replaced with migration entry, and then we replace the migration entry with a new location.
Yeah, I think this is an optimization of some sort. I suspect it wasn't fully thought through.
Well, because the one I was looking at in particular, the one in migrate page add and mem policy, that one is like from forever ago and just kind of like hasn't been touched too much. I think it had something to do with anonymous pages. Or I think that was the goal. I don't remember it directly.
I
But
remember that for like NUMA balancing, NUMA policy stuff, this migration had was implemented before general migration of THP was added.
mhm.
So it's just historic accident that we have this code. Ideally, it should be consolidated and we should have one code that handles basically any folios, regardless of size.
Hmm.
Yeah, I honestly think that this is just buggy.
Yeah, like when I was looking at it, that's what I thought, and I was like, I don't know if I wanted, or it's not even I don't know if I want to, but I'm too confused on what's going on with large page or not like compound pages or large folios here, and I'm just like a little lost.
I would worry to touch such code just because I would need to retest it on how it
Mhm.
will affect like NUMA policy, NUMA balancing, because
Yeah.
I don't have idea how to test it properly. And like when I try to look at test that mail contains, I get scary about how to get it stopped. And yeah, I don't know.
This does seem like a heuristic rather than for correctness sake. So I wouldn't be surprised if it has been wrong for many years and nobody's noticed because we rarely migrate THPs. And we only just added multi-page folios for file systems, and just
Mhm.
nobody has noticed that this could be better or should be better.
Maybe it's right policy like for NUMA balancing to only migrate pages that mapped once, just because for those pages we're sure that we do the right policy change. But
here's the thing: a page map count of the head page of a THP is going to be 0. Because we're not going to check the compound mapping, we're going to check the number of times that specific first page is mapped by a PTE.
Yeah. So we check there only. Right.
Yeah. So I think to capture the spirit of this, we'd actually want to check folio total map count, but that is a expensive thing to be checking. So I'm inclined to have it the way that you have it. Like we're going to check how many times is the whole folio mapped. Unfortunately, that's going to go horribly wrong for file pages because multi-page, because we never set the compound map count for those because they always get mapped with PTEs. So I think this is all wrong, but I don't have a good way of figuring out what it should be.
Yeah. That's kind of been my problem when because at first I was like, oh, you know, folio map count should be okay because I didn't consider the large folio weirdities.
I also wonder if I
oddities.
shouldn't get rid of folio map count as a predicate. It seems like it's easy to inadvertently change and then not realize what you're getting, because
Mhm.
there's always multiple things you might want to be asking about. Like you might want to know folio total map count, or you might want to know folio entire map count.
Mhm.
And if you have to think, hang on, what's the difference between those? Well, at least you're thinking about it, rather than just blindly writing folio map count and thinking you're getting the right thing when actually you're not.
But yeah, I guess then a little follow-up question just comes to like, because I'm not too familiar with the migration. How does, because you said it doesn't happen too often for THP pages anyways. How does it work for compound pages? Like, because it only like checks the head and then adds the head to the list. So does it migrate the whole page together? Or the
Yes.
whole, yeah, okay. Huh. But yeah, it's and that's where it just comes back to, it's like, what is the check really or I guess that's, yeah, because I feel like the total map count or the folio total map count is what we want to check, but like you said, it's expensive.
I mean, I did just say that, but it's actually the wrong thing to check as well, right? Because total map count, like if you have an order 2 folio and the whole thing is mapped to one process, it's going to have a total map count of 4.
Yeah.
So rather than comparing it to 1, we would need to compare total map count against number of pages in the folio.
Oh.
Yeah. See, this gets tricky.
Yeah.
Not to mention what I said earlier, which is that even scanning to find the total map count is kind of an expensive operation for this kind of, let's see if we should skip it.
Hmm.
Mm.
Yeah, well, that's a problem, isn't it?
It is.
Well, I have no clue. I'll have to think on it, I guess. But
Yeah. And we should probably move on because we're getting perilously close to the end of the meeting. Anything else you wanted to bring up before?
nope, that was basically all I was looking at. So
Okay. Anthony, what would you like to talk about?
I don't really have anything because I've been pulled in some other work. I'm just trying to keep apprised of what's happening. I hope to get back into things in about a week or 2.
Sounds good. Thanks. Alexander?
No update on my end at the moment. I'll be back at it like probably next week.
Cool. Thanks. Hyungong?
I have things. I spent almost 3 weeks to deal with the spot tiny bugs, so it seems it's Plasmic found the root cause. So back to the page select flag, moving page select flag. So no new things for me.
Yeah, okay. I promised to send you my thoughts about that, and I didn't do it. Sorry about that. I will do that today.
Oh, thanks.
Thanks. David Law.
No update on my side.
Okay. Ziyan?
Nothing from my side. Thank you.
Okay. And Yuzhao?
Nothing to report. I'm still out of office.
Okay. Sounds good. Well, after having thought we were bumping up against the end of the window and having to cut people off, it seems like we're finished early. Anything anybody else wants to bring up before we leave? All right, nobody's gone off mute. Thank you all for coming. For those who celebrate, happy Lunar New Year, which is Sunday, I believe. And yep, speak to you all again in 2 weeks. Thanks all.
Thank you.
Thank you.
Thank you.
Bye.